I'm Joseph Kim.
I'm Carissa Yoon.
I'm Stephen Yu.
And we are Innovation for Irrigation.
When given the opportunity to spend an entire year on a project, we knew we wanted to make something that would benefit our education and the lives of others.
That's where the idea for Irrigation came in. In 2017, we had the opportunity to spend a week of our summer in the third world country of Haiti. There, we did small service projects such as planting trees and painting homes.
But one of the most significant memories we remember is the trouble that the Haitians had with receiving and transporting water. So after seeing this, we decided to build a water ram.
We wanted to build a hydraulic pump that is able to pressurize water input, store water in a chamber, and deliver water from a hose. The idea sounds simple, but this project presented great problems and widened our engineering experience.
So, we headed into this project with basic knowledge in physics and engineering. But throughout the course of this year, we were able to build a greater foundation in specific engineering aspects, such as water pressuring systems, pipe systems, hydraulic dynamics, and mechanical structures of specific parts and tools.
And our year began with simple research of possible ideas for a water transportation system. And our first design was inspired by Kickstart International, which is based in Kenya. This foundation made a water pump that was a human-powered treadle irrigation pump, which is called the Moneymaker Max.
We also found out that only about 4 to 6% of Africa is irrigated. Its long dry seasons often result in little food and widespread hunger, with rains becoming increasingly unreliable. Using the Moneymaker Max pumps, farmers are able to grow more food year-round and start profitable farming businesses.
But after learning how the pump worked, we found out this specific design required advanced welding for its particular parts, especially the steel treadles that will allow proper foot placement and attachment to the cylindrical valves. Because we did not have the proper technology and budget for this design, we decided to point our project towards a new direction.
With advice from Mr. Barrett, we concluded to design and build a water ram pump. A hydraulic ram is an efficient way to move water uphill without relying on electricity, gasoline, or any other sort of polluting energy, which is a huge plus for a developing country, such as one in Africa. The hydraulic ram is an automatic pumping device that uses the energy contained in the flow of water running through it to lift a small volume of water to a higher elevation. The hydraulic pump uses the kinetic energy from downflowing water to lift water towards a higher elevation. The device uses the energy created from low head water as the driving force to pump a portion of this water to a head that is much higher than the supply head. Because water flows continuously in the stream, the hydraulic pump also operates continuously as the direct result of the water head energy. Hydraulic rams are generally simple devices that consist of two moving parts, which is an air chamber and an air valve, or the waste valve and delivery valve. Hydraulic rams operate by the opening and closing of the waste and delivery valves. When the waste valve closes, a high pressure rise is created in the drive pipe, and the air valve allows air into the hydraulic pump to replace the air absorbed by the water due to the high pressures and mixing in the air chamber.
Most of the parts were simple mechanics we could buy and accommodate to each other through the use of male and female adapters and connectors. We had a rough draft of supplies by the end of October 2018, which included one 1-inch elbow, two flapper valves, one 1-inch T, two all-thread connectors, one 1/2-inch to 1-inch reducer, one 3 to 4 feet PVC pipe, and one black poly pipe hookup.
We were able to buy most of our parts and tools at Ace Hardware and Home Depot, along with several other supplies as we adapted our design to what was unavailable.
But as we began to assemble our design, our first major problem occurred. We could not find the proper flapper valves that would serve as the waster valve and delivery valve. Both of these valves were crucial to the development of the free-flowing aspect that relied solely on gravity and a self-pressurizing system. We could not find the specific metal valves that had a flapper gauge on both endings, so for 3 weeks we were unable to continue with our design. But we eventually found out about a PVC flapper valve that serves the same function and actually reduces the amount of water that is wasted and when the waste valve opens.
After we had all of our parts and tools together, it was time to begin construction. This part of the project was the easiest part, besides having to adjust certain measurements as needed and to change parts if the store did not have a supply for the specific measurement we needed. However, it was relatively simple to connect each part together and build the basic design for our water ram.
After successfully building our first design, we were satisfied to see that the pump was able to deliver water from an input waterhead to an output waterhead that was above the elevation of the input source. Unfortunately, we noticed a problem with our water flow.
Alright. First test. Third test. Steven is turning on the hose. Candle will not blow out yet. Take 3/4. We have added the cap.
Yeah!
Working. So we need to fix that part.
We noticed that there was an excessive amount of water leakage across the entire hydraulic pump. Part of this leakage was due to the only slightly tightened parts due to testing if the pump would actually work. But even after fully tightening each part with pliers and wrenches, we still seemed to have leakages that wasted valuable water.
We finally realized that there would always be spaces between each connecting pieces, so we decided to apply Teflon tape to each intersection of parts. And after successfully applying the Teflon tape, we were satisfied to see that the hydraulic pump was no longer leaking. So we were close to being completed with our project, but still needed a few more steps to be completed with the final design.
Test 6. We fixed the issue of the water leakage.
Almost.
Teflon tape, almost, yes. Okay.
We added steel bearings with a rubber lining to the base and PVC chamber sections of the hydraulic pump in order to allow it to stand against a wooden board and be ready for official presentation. In addition, we decided to spray paint the PVC chamber a dark blue and paint the wooden board it was clamped against to add an aesthetic appeal.